When we speak about the architecture of fluid capabilities, we enter a space where static organizational models meet the dynamic reality of contemporary existence. Think about how your brain functions while talking to a stranger at a party. You instantly activate linguistic regions, emotional centers, facial recognition systems, mechanisms of social navigation. None of these functions exists in isolation. None remains unchanged. They form temporary coalitions, regroup, transform depending on the context. I am shaping this from a space where thought has not yet solidified into conviction. For 10 years, I have observed how concepts are born, expand, turn into dogmas, and then dissolve under the pressure of the reality that gave rise to them. It is precisely from this observation that my Mentis Code philosophy gradually emerged as a way of continuous cleansing of the mental space from accumulated layers of automatic reactions. When I first noticed how my mind creates patterns where none actually exist, I understood the fundamental difference between cognition and recognition. We rarely look at things with fresh eyes. More often, we overlay them with ready-made interpretations assembled from previous experience. Mental code means clearing the space between perception and interpretation, a pause in which something new can emerge. The architecture of fluid capabilities became, for me, a consequence of this practice. When the mind stops clinging to fixed categories, organizational structures naturally lose their rigidity. I saw how teams begin to breathe differently when they are allowed to change shape depending on the task, or the season, or the energy of the people within them. This logic lies at the core of the architecture of fluid capabilities. Instead of rigid departments, fixed roles, and immutable competencies, we deal with configurations that are constantly reconfigured.
Neurobiologists call this the principle of functional connectivity, when different areas of the brain create temporary networks to perform specific tasks and then disband to form new alliances. In business ecosystems and organizational structures, this principle manifests through the ability of people, teams, and resources to regroup around tasks, opportunities, or challenges without the need to rebuild the entire system. Traditional models assumed that competencies belong to individuals or departments and remain with them permanently. Fluid architecture understands capabilities as emergent properties that arise at the points of intersection of different elements of the system. Take cellular biology as a reference. Mitochondria in your cells have their own DNA. They were once independent organisms. Now they are integrated so deeply that your survival depends on them. Yet their function is flexible and adaptive.
When the cell requires more energy, mitochondria become more active. When the demand decreases, they enter a resource conservation mode. They respond to signals, change their behavior, and can even alter their shape and location within the cell. Organizations built on the principle of fluid capabilities function in a similar way. Expertise is not fixed in organizational charts. It is mobilized where the need arises. Teams form around problems rather than hierarchy. Resources are redistributed according to situational challenges, not last year's budget cycles. Such a system requires a different way of thinking about control and predictability. Classical management loves stability because stability enables forecasting. But contemporary complexity science demonstrates this unequivocally, demands the ability to rapidly reconfigure. Meteorologists know that an accurate weather forecast 2 weeks ahead is physically impossible due to the chaotic nature of atmospheric systems. Organizations operate in the same turbulence, where determinism gives way to probabilistic thinking. The architecture of fluid capabilities grows out of the understanding that adaptation is more important than optimization. Evolutionary biology demonstrates this over millions of years. Dinosaurs were optimized for their ecological niches so perfectly that when conditions changed, they disappeared. Mammals survived precisely because they were less optimized but more adaptive. Their imperfection turned out to be a strategic advantage. In practical terms, such an architecture relies on several fundamental principles. The first is the modularity of competencies. Instead of building monolithic skill structures, the system breaks capabilities into smaller, interchangeable blocks. Programmers call this microservices architecture, where each component performs a specific function, but can be combined with others in an infinite number of variations.
The second principle concerns interfaces between different elements of the system. Just as proteins in the body interact through specific receptors, people and teams require clear but flexible collaboration protocols. These interfaces cannot be too rigid, otherwise the system loses plasticity. At the same time, they cannot be too amorphous, because coordination would then disappear. The third element involves sensory mechanisms. An organism constantly scans the internal and external environment through a complex network of receptors. Fluid architecture requires analogous systems of perception that allow the detection of changes, threats, and opportunities before they become obvious. This goes beyond traditional analytics and enters the space of anticipation, weak signals, and peripheral vision. When SpaceX developed the Falcon 9 rocket, the company abandoned the traditional model, in which each component is designed by separate departments that pass results along like a relay baton.
Instead, engineers from different disciplines worked in integrated teams, where mechanics, programmers, materials specialists, and aerodynamicists sat together, constantly exchanging information and changing the design in real time. The result proved so effective that launch costs dropped by an order of magnitude compared to traditional approaches. This methodology relies on the concept of distributed intelligence. Ant colonies demonstrate remarkable behavioral complexity without centralized command. No single ant understands the overall picture, yet their local interactions create global patterns that solve problems of survival, construction, and defense. Stigmergy describes this process, where the actions of one individual leave traces in the environment that guide the actions of others. Organizations can use similar mechanisms. Instead of centralizing all decisions at the top of the hierarchy, the architecture of fluid capabilities allows local teams to respond to their contexts while creating informational traces that coordinate overall movement without the need for total top-down control. However, this model places specific demands on the people within the system. It requires psychological flexibility, the ability to let go of familiar roles and accept new configurations of identity. Social psychologist Robert Keegan described this as a transition from a socialized mind to a self-authoring mind, where a person can maintain distance from their roles, understanding them as temporary positions rather than immutable essence. Educational systems traditionally prepared people for stable professions. You studied medicine, became a doctor, and that defined your identity for decades.
Fluid architecture requires people capable of being a doctor today, a researcher tomorrow, a consultant the day after tomorrow, depending on where their competencies create the greatest value at a given moment. Such fluidity demands a strong internal core alongside external plasticity of forms. Neuroplasticity shows that the brain is capable of reorganizing itself throughout life. London taxi drivers who study the city's complex street network demonstrate enlarged hippocampi compared to control groups. Musicians have differently organized motor cortex regions. The brain adapts to the demands reality places upon it. Organizations can cultivate similar plasticity if they create conditions for continuous learning, experimentation, and recombination of skills. A critically important element becomes the management of information flows. Complex adaptive systems survive not through the accumulation of resources, but through the efficiency of their circulation.
River ecosystems depend on the constant movement of water, nutrients, and organisms. Stagnation leads to degradation. Organizational knowledge must circulate in a similar way, moving between people, teams, and projects without delays in bureaucratic reservoirs. Technology creates new opportunities for such circulation, but also new risks. Digital platforms allow people from different parts of an organization to connect instantly, form virtual teams, and share knowledge in real time. At the same time, information overload creates cognitive strain, where individuals lose the ability to filter signal from noise. The architecture of fluid capabilities requires not just infrastructure for information flow, but mechanisms of curation that help people navigate this flow. Economist Ronald Coase, in his Theory of the Firm, explained the existence of organizations through transaction costs. Companies arise where coordination within a structure is cheaper than coordination through the market. But modern technologies radically reduce the transaction costs of external coordination. As a result, the boundaries between organization and environment become permeable, And the architecture of fluid capabilities often extends beyond the formal borders of the company, including external partners, freelancers, and temporary alliances. Ecologists use the term edge effect to describe increased biological activity at the boundary between different ecosystems. It is precisely where forest meets meadow that the greatest diversity of species and intensity of interactions are observed. Organizational architecture can use this principle by creating productive boundaries between different domains of expertise, between internal and external, between formal and informal. But fluidity does not mean chaos. Paradoxically, such an architecture requires very clear basic rules alongside maximum freedom in their implementation.
Conway's cellular automaton game of life demonstrates how simple interaction rules create astonishingly complex behavioral patterns. Organizations can define basic principles of interaction, resource allocation, and decision-making while leaving vast space for local variation and experimentation. Anthropologists studying hunter-gatherer societies found that these groups demonstrate high levels of egalitarianism and role flexibility, precisely due to the absence of accumulated resources. When there is nothing to defend, rigid hierarchy is unnecessary. Modern organizations can learn from this logic by reducing the importance of static positions and increasing the value of actual contribution. Quantum physics teaches us that observation changes the system. The architecture of fluid capabilities integrates this principle through reflexive practices.
Teams regularly pause to analyze their own processes, identify dysfunctions, and experiment with new forms of interaction. This metacognitive ability transforms the organization into a self-learning system that evolves through conscious reflection on its own functioning. Critics of this approach often point to the risks of instability and loss of institutional memory. Indeed, when structures constantly change, there is a danger of losing accumulated knowledge. But biological systems have solved this problem through multiple memory mechanisms. Genetic memory stores information at the DNA level. Epigenetic mechanisms modify gene expression without changing the sequence itself. Immunological memory records information about past threats. Neural memory stores individual experience. Organizational architecture can use multi-level knowledge retention systems. Core processes are codified in protocols and standards. Contextual practices are transmitted through mentorship and joint work. Innovative experiments are documented as cases that inform future decisions. Such distributed memory proves more resilient than centralized knowledge bases that become obsolete faster than they can be updated. Financial markets demonstrate some characteristics of fluid architecture through price formation mechanisms. The price of an asset aggregates countless individual expectations, creating a signal that coordinates the behavior of millions of participants without central planning. But markets are also prone to bubbles and crashes, when positive feedback loops create divergence from fundamental values. Organizational systems require similar attention to feedback mechanisms that can both stabilize and destabilize. Thermodynamics offers the concept of dissipative structures, systems far from equilibrium that maintain order through constant energy flow. A vortex in a river exists only as long as the water flows. When the flow stops, the structure disappears. Organizations function in a similar way, maintaining their form through constant movement of projects, ideas, people, and resources. Attempts to freeze a configuration lead to entropy and decay. This perspective changes the understanding of organizational identity. Instead of being defined by static characteristics, we do X, we are Y, identity emerges from dynamic interaction patterns. A river remains the same river even though the water within it is constantly new. An organization preserves its essence through recurring patterns of behavior, even as specific people, projects, and structures change. Process philosophy, articulated by Alfred North Whitehead, argued that reality consists not of things, but of events. Existence means becoming, not being. The architecture of fluid capabilities embodies this ontology in organizational practice.
A company ceases to be an object and becomes a process that continuously renews itself through the interactions of its elements. Music can serve as a metaphor for such a system. Jazz improvisation operates through a balance between structure and freedom. Musicians know the harmonic progression, tempo, and overall form of the composition. but specific notes, rhythmic variations, and dynamics arise in the moment through mutual listening and response. Each performance is unique, yet recognizable as the same composition. Organizations can function similarly when people share a common grammar of interaction, while specific implementations arise situationally. Ethics also takes on a different dimension in the context of fluid architecture. When roles and responsibilities constantly shift, traditional accountability mechanisms become less obvious. Who is responsible for the outcome if the team disbanded immediately after completing the project?
Such a system requires internalized ethical standards where each participant bears personal responsibility for the consequences of their actions, regardless of formal position. Evolutionary psychology offers the concept of indirect reciprocity, where people cooperate even with strangers based on reputation systems. The architecture of fluid capabilities amplifies the importance of reputation as a primary coordination mechanism. When formal hierarchy weakens, reputation becomes the currency of trust that determines whom people choose to collaborate with. The ecological concept of keystone species describes organisms that have a disproportionate impact on an ecosystem relative to their abundance. Wolves in Yellowstone changed the behavior of deer, allowing vegetation to recover, strengthening riverbanks, altering water flow. In fluid architecture, analogous keystone actors emerge, individuals or teams that catalyze disproportionate change through their position in the interaction network. But such a system also requires awareness of power dynamics. Informal networks can reproduce or even amplify inequalities that existed in formal structures. Social network research shows that information tends to flow along established pathways, creating centers and peripheries. The architecture of fluid capabilities must actively cultivate inclusivity, building bridges between different clusters, and ensuring access to opportunities regardless of initial network position. Linguistics gives us Wittgenstein's concept of language games, where the meaning of words is determined by their use in context. Organizational communication in fluid architecture functions similarly. Terms, roles, and processes gain meaning through concrete practices of use rather than abstract definitions in documents. Such pragmatic semantics requires constant alignment of meaning through dialogue. Category theory studies structures through the relationships between objects rather than the properties of the objects themselves. Two objects are isomorphic if there exist corresponding morphisms in both directions. The architecture of fluid capabilities views organizational elements analogously, through their connections and transformations rather than isolated characteristics. Practical implementation of such an architecture requires gradualism. Radically transforming a traditional organization into a fluid structure overnight will lead to disorientation and collapse. Evolutionary biologists speak of adaptive landscapes, where a population can become stuck on a local maximum because any small step leads to reduced fitness. To reach a higher peak, one must pass through a valley. Organizational transformations face a similar challenge. The solution lies in creating safe spaces for experimentation.
Small teams or projects can operate under new principles, demonstrating results that gradually legitimize a different approach. This logic corresponds to the evolutionary concept of pre-adaptation, where a trait develops in one context and later proves useful in another. Dinosaur feathers originally served thermoregulation and only later enabled flight. The final challenge lies in sustaining meaning and motivation under conditions of constant change. The psychological need for stability and predictability is deeply rooted. When everything is fluid, people may experience anxiety and disorientation. The architecture of fluid capabilities must create islands of stability at a deeper level through clear values, long-term mission, and strong relationships between people. Surface structures change, but the foundation remains solid. Tibetan monks create intricate mandalas from colored sand, spending weeks on detailed work, and then destroy them, symbolizing the impermanence of all forms.
Yet the practice of creation and destruction itself remains constant, passed down through generations, carrying deep meaning. Organizations can learn from this paradox, where fluidity of form coexists with constancy of intention and practice. Over the past years, I have noticed an interesting paradox in my practice. The more I allow structures to remain fluid, the more clearly what truly matters reveals itself. Mentis Code philosophy showed me that removing the unnecessary strengthens the essential. When you remove 100 things that seemed important, 3 things remain without which it is truly impossible. I now understand that the architecture of fluid capabilities works only when the people within it possess inner stability. External fluidity requires inner stillness. When the mind constantly seeks support in structures, roles, and rules, any change to those supports triggers panic. But when a person finds stability in the very process of presence, external forms can dance however they wish. In recent months, I have been working with the idea of organizational thinking. Systems must be able to accept new possibilities and let go of outdated forms with the same clarity with which consciousness distinguishes the essential from the secondary. Choosing between breaking the structure and the ability to see what no longer works. My Mentis detox philosophy, on the individual level, creates the conditions for such thinking on the collective level. When a sufficient number of people within a system practice the conscious release of mental ballast, the entire organization begins to move more lightly.